Hey guys, what's up? It's Eric with Advanced Level Automotive. Welcome back to the channel. Welcome back to another video. Today, we're here at the shop to take a look at this 2013 Dodge Durango. It's got the V8 5.7 liter engine. And what the shop is telling me is that they replaced the alternator. Well, they actually replaced the alternator like 3 times and it's still not charging. They went through 2 different aftermarket alternators and even installed a used OEM Mopar part. So we're gonna start by doing some basic charging system tests. Let's pop the hood, find where the little lever is at, right there. All right, so here's our 5.7 liter Hemi engine. And if we look down here, this is where the alternator is located. Now this one, if I'm not mistaken, the battery is actually located underneath the passenger seat. Over here, we do have some connections where you can jump start the vehicle. This one's for the negative terminal and this one over here is for the positive terminal. So I'm gonna grab my Autel PowerScan. We're gonna hook it up to the battery. I'm gonna toss the leads to the back. Now if we hop inside, you can see our battery is located underneath the passenger seat. Let me go ahead and hook up the terminals. This one's the negative, and the one back there is the positive. Make sure we got a good bite and that's not going anywhere. All right, let's see if we can start this thing up. Hopefully we got enough juice in the battery. They did mention to me that the battery was low, so let's see if we can crank this thing. Okay, the engine actually started up. Let's move under the hood. All right, so moving under the hood, the first thing I want to do is we want to take a look at our PowerScan. I'm going to push the little rocker switch to the positive side and we're going to see how much battery voltage we have. And check that out, we only have 10.5 volts, so this alternator is not charging at all. Next up, I want to take the tip of the power probe and touch it to our positive terminal here for the jump start. And once again, you can see we only have 10.5 volts. Next thing we want to do before this engine dies, because I don't know if it can stay running, is we want to try to touch the battery post directly on the back of the alternator and see if it's charging. All right, I don't know if you guys can see that battery cable right there coming off the back of the alternator. I'm going to try to shove this in here and see if I can get some good contact. I know it's kind of hard to see, but hopefully you guys can see it. Oh man, we're barely at 8 volts down here, so I think our voltage is dropping really fast. Yeah, the motor sounds like it's struggling right now, but this is coming directly off the back of the alternator, or at least at the end of this terminal right here. You know, that's not to say that we might not have some corrosion in this terminal where it connects to the alternator. I can't really get my power probe behind it to get directly onto the stud. Let me see if I can find like an alligator clip or something. All right, so I've got me just a little lead with an alligator clip on the end of it, and then on the other end it's got a little banana plug. The cool thing about the PowerScan is you can pop off this needle right here and we can plug in directly to the banana port like that. Now I'm just gonna go ahead and try to get this directly onto the stud on the back of the alternator. You guys hear that? Sounds like the engine wants to die. It's getting ready to stall. Yep, it just stalled on us. Let me see if I can get onto the stud right here on the back of the alternator. Okay, I've got a good bite on the stud coming directly off the back of the alternator. Of course, our engine stalled out, and as you can see, we only show 7 volts, so that's not enough to start the vehicle up. Let me go get my jump pack, hook it up, and we'll see if we can get this thing started again. Let's grab our jump pack, and we're gonna plug this in. Actually, we could probably just set it up here out of the way. Grab our cables, hook one up right here, then hook up the positive right over here. And as you can see, we're only showing 7 volts, so we're gonna turn this on. Let's try and restart this thing. Off, and then back on. All right, as you can see, the engine is now running. Let's take a look at our PowerScan and see where our voltage is. 11.5 volts. Let's compare that to the jump pack. Yeah, 11 volts. So okay, this is coming directly off the back of the alternator, meaning that the alternator is not charging. Let's try disconnecting the connector on the back of the alternator to see if this alternator will full field. So I'm gonna just carefully stick my hand in here. I know I can't show you guys this, but I'm gonna unplug the connector because it's easy to get to right here on the back side. Oh, it's got a little clip on it. Let me wiggle it out. Come on. Wow, that sucker does not want to come out. I don't want to leave this running too long because then it's going to get hot. So let's go ahead and shut it off real quick. All right, engine's off. Now let's see if I can get this thing unplugged. Ah, there we go, came out. Let me shut the sound off on this because it's kind of annoying. So you can do that by just selecting that little speaker right there, and then you hold this button and you see how it X's it out, so no more sound, and you can still see our voltage. Okay, so I don't know how well this is going to show up on the camera, but you can see I've got the connector disconnected. It's right there. So now that we have that unplugged, let's try to start this thing back up and see if this alternator charges at some type of default value. All right, so we're going to start it back up again. Let's go ahead and check our reading, we're still only seeing 11.5 volts coming directly from the alternator. This thing is not even trying to charge. You can see the belt is turning, so it's not a problem with that. There's got to be an issue with either this alternator being bad or some type of connection issue. And like I said, guys, this is the third alternator that they put on this, so the probability of it being bad is kind of low, but you know, we need to make sure we do all of our tests before we can condemn the alternator. Alright guys, so before we go any further, I want to take a moment to stop and take a look at the wiring diagram. This is going to give us a better idea of what to test. So if you take a look over here, you can see we have our generator or alternator. It's a very simple, very straightforward design. First of all, we have this cable that comes from the battery. This is going to be the positive battery cable that attaches to the back of the alternator on the stud. Then of course we have this 2-wire connector. The 2 wires from this connector go directly to the PCM. On pin number 1, we have something called the generator source field. And on pin number 2, we have something called alternator sense. Now, according to the service data, this alternator is controlled by the PCM. The computer monitors the voltage on pin number 2, then it regulates the field on pin number 1, and it does so by sending a pulse width modulation signal. So depending on the pulse width modulation, the alternator will either increase or decrease current. Now, a couple of important pieces of information that they add here. For one, they tell us that the alternator is internally grounded. And the other piece of information that they give us is that the pin number 2 is internally connected to the B+ terminal, meaning that pin number 2 on the connector for the alternator internally is attached to the stud on the back of the alternator where the battery cable connects. This lets us know that pin number 2 should always have battery voltage. So again, pin number 2 is how our PCM monitors the battery voltage. And like we mentioned before, pin number 2 internally is attached to the battery cable. Then pin number 1 is where the PCM sends the pulse width modulated signal to regulate the output of the alternator. So now that we have a basic understanding of how this works, let's move back over to the vehicle and do some testing. All right guys, so I've got my little back probe. I'm gonna go ahead and back probe our pin 2 on the connector for the alternator. We're gonna plug it in and we're gonna check our value. Okay, so I've got my back probe in on pin number 2 of the connector. Let me go ahead and plug it in. Okay, I felt it click. Let's go ahead and take a look at our reading. We have 8.8 volts. Okay, so according to the service data, they're telling us that that pin number 2 internally is connected to the B+ post on the back of the alternator. So that means whether we check it with the key on or off, engine running or not, we should still be seeing the same value. You can clearly see that over here we had 8 volts. Well, what the heck? Now I'm showing 11.5 volts. That's weird. But anyway, during the time when it was showing 8 volts here, I was looking up here at the jump pack and we were showing 12 volts. And right now we're looking at 11.6 on our PowerScan. Let me try to do this. I'm gonna set this up right here. I'm gonna try to move the battery cable on the back of the alternator and I'm gonna see if this number changes. So I'm wiggling the cable. I don't see the number moving. Let me wiggle the connector. I'm wiggling the connector, but I don't see anything. Okay, that's interesting. I wonder what would happen if we started it up. So I'm just gonna go ahead and start this thing back up. And let's take a look at our reading. Check it out, guys. We dropped back down to 8.5 volts. Let's compare that to the stud on the back of the alternator. Remember, we still have this Alligator clip connected back there. So I'm gonna disconnect this from the PowerScan and I'm gonna connect the yellow lead and check it out. We have 11.5 volts. Does that mean that this alternator is bad? Like maybe it's got high resistance between the B+ terminal on the back of the alternator and the pin number 2 on the connector. I don't know. Alright guys, so check this out. After doing a little bit more research on the subject, I found this technical service bulletin through a forum on IATN. Now this TSB was made by the company Hemi, which is an aftermarket alternator manufacturer, but they did a really good job with this bulletin that explains to you how these alternators on these Chryslers work and how you can test them. The information in this bulletin is super helpful, and I'm going to see if I can figure out a way to maybe link it in the description, so if you guys want to check it out. But anyway, the bulletin starts out by explaining that the alternator that we have is what they call a single field terminal. That is noted by the style of the connector. You can see they have a little drawing on the right side. The pin number 1, they call it the F or the field, and the pin number 2, they call it the B or the Kelvin sense. Now they go on to explain that in 2008, Chrysler alternators began using the single field terminal, and what we have is the Kelvin sense circuit, which is used by the PCM to monitor the charging voltage. Now one of the interesting things that they point out here, if we scroll down, they go into a little bit more detail about the Kelvin sense circuit, and the most important thing I think here is that the PCM directly monitors this circuit that has no current flow and therefore no voltage drop. Inside the alternator, the sense circuit does have a 2.4 k ohm resistor, but because the circuit has no intended ground path, there is no current flow. What they mean by that is that yes, our pin 2 internally inside the alternator is directly connected to the battery positive post. However, internally there is a 2.4 k ohm resistor. So that means that the voltage from the alternator coming out of pin 2 is in fact system voltage. However, it's a very, very weak signal. This is likely the reason that when we put our meter onto this circuit, we're seeing about a 3 to 4 volt difference between the battery positive and this sense circuit on pin number 2. My guess is that it's because the meter is actually giving it a path to ground. So it actually may be normal to see 8 or 9 volts on this line. Now, the other cool thing they show us on this TSB is how to full field or test the alternator. Now, according to them, if we attached a fuse power feed to our pin number 1, the alternator should full field and begin charging. So that tells us that the pulse width modulated signal that comes from the PCM to our alternator on pin number 1 is a positive battery power source that's coming from the PCM. That's how the PCM is regulating the voltage output of this alternator, is by sending it power. This is some really useful information that's going to help us diagnose our problem. Let's move back over to the truck and finish with our testing. Alright guys, so moving back under the hood, right now I've got my back probe connected to our pin number 1. Again, our pin number 1 is the control that comes from the engine computer going to the alternator. Right now on the meter, we're showing ground, which is normal to see because again, this terminal is internally grounded to the alternator. So I'm going to go ahead and start this engine up. We're going to see if we have any activity on there. Okay, so once again, we're going to start this thing up. Now let's check to see what we have on our PowerScan. And as you guys can see, we have 0 volts. We got nothing coming from the computer. Again, we know that we should have a pulse width modulated voltage or power feed coming from the PCM going to the back of the alternator. We're not showing that. We should at least see some type of activity, some type of voltage. So the next thing I want to do is hook up a scan tool. And we're going to check to see if we have any data PIDs. Plug in our dongle. We're going to go into Diagnostic. It's already auto ID'd our vehicle. There's our VIN number. We're going to hit OK. Again, 2013 Dodge Durango. And what I want to do is I want to go into the engine control module and see if the manufacturer provides us a data PID.
¿La troca esa viene para aquí con ustedes?
¿Cómo?
¿La troca esa viene para aquí con ustedes?
No, es que yo no trabajo aquí. Puede preguntarles allá adentro.
Sorry about that. Somebody interrupted me. Anyways, like I was saying, I want to go into the engine control module and see if we have any data PIDs related to the alternator. So we're going to go into live data. Let's go ahead and scroll through these data PIDs and pick out anything that has to do with the alternator or generator. Here we have one for the generator duty cycle. Let's continue and see if we have any more. Okay, so I just went through this entire list and that is the only data PID that we have for the generator. Let's go ahead and click, and now we can see our generator duty cycle. Again, this I believe should be the control or the pulse width modulated signal that the PCM sends to the alternator. Right now we're at 0. Let's go ahead and start this thing up. All right, the engine is running, and as you can see, our value is shooting up 80, 90, 100%. That means that our PCM is trying to send full power to our alternator. But when we look under the hood at the PowerScan, you can see that we don't have any signal reaching the alternator. So I think the next thing we need to do is go after the PCM. All right guys, so really quick, before we chase down the PCM, I do want to do a quick test on the alternator. I'm going to try to full field it by sending a power. I think that should be the right size. All right guys, so hopefully I can show you how I have this connected. If you look, you can see I have my red lead attached directly to the pin on the back of the alternator. Now, I couldn't see it because it's facing rearward, so I basically just had to feel it out, but I'm pretty sure I got a good connection. All right, so as you can see, we're showing a ground. I'm going to leave the plug disconnected. We're going to start this engine up, and then we're going to use this little rocker switch to give it direct power. Now, this PowerScan does have a built-in circuit breaker, which I believe is rated at 8 amps, so we should be pretty safe sending this power to the alternator. I'm going to go ahead and start this thing up. Let's move back under the hood. All right, so we're showing 11.3 volts. I'm gonna go ahead and flick the rocker switch. We're gonna send a power to the alternator, and we're gonna see if this thing starts to charge. So I'm gonna flick it on. And check it out, guys. Our voltage is shooting up, 13.7, 13.8. That's what we wanna see. This proves that our alternator is actually working. All we're missing is the power that's supposed to be coming from the PCM to the pin number 1 on the back of our alternator. Let's start the process of checking the PCM. Okay, so I went ahead and I removed the C1 and C2 connectors from the PCM, and I went ahead and I took the little back pieces off. I went ahead and removed the little covers. Over here on the C2 connector, you can see that I'm back probed on pin number 19, which is our brown and purple wire. That's going to be our computer control for the alternator. And if you look right here on the meter, you can see that we're at 0 volts. Oh, by the way, I do have the alternator connected. I removed my test lead and I plugged the connector back in. So now we're gonna go ahead and plug this back in. Okay, so we're all hooked up over here. Again, we're showing our ground through the alternator. Let's go ahead and start this thing up. Moving back under the hood. Again, taking a look at our scan tool, you can see that our generator duty cycle is 100%. That means this computer should be sending out 100% duty cycle. But if you look over here on the meter, we're still showing 0. And we're checking this directly at the PCM. What does that tell us? That tells us that this PCM is not sending out the power. Now at this point, we can probably safely say that this is gonna need a PCM, but you guys already know on this channel, we test, we don't guess. So we're gonna go the extra mile and check our powers and grounds at the PCM, make sure that it has everything that it needs in order to function properly. Then we can call a bad PCM. All right, so in order to test our powers and grounds, I'm gonna be using this load tester. Looks like a test light, but it actually has a button right here. And when you push it, it gives a load of about 800 milliamps. You can see on the back side, it has an incandescent bulb right here. Really awesome load testing test light. We're gonna go ahead and start by testing our grounds. So I'm gonna connect our Alligator clip to our power. So we'll just connect it up here. Hopefully you guys will be able to see, but we have 3 grounds on this one connector. Starting with this pin number 9, I'm gonna back probe it. Then I'm gonna take my little test lead, attach it to the tip of my test light. And as you can see, we're showing negative 11.7 volts. Now we're gonna push this button and apply a load. Then we're gonna watch to see how far down this voltage drops. So you can see our voltage drops down to about 11.1 and our light bulb is lighting nice and brightly. This ground passes the test. Let's switch over to our next ground, this one right here. Again, we're showing a ground here. Let's click the button. Our test light lights up nice and bright and you can see 11.1 volts. That's good. We don't see a significant drop. It's normal to see some drop because we're putting a load on it. Now let's check the next pin. Again, the same thing, 11.7. We're going to click the switch. Our test light lights up nice and bright and we have 11.1 volts. So our grounds here are good. Let's go ahead and check our power. I'm gonna move our test clip over to a ground. Then I'm going to back probe this red wire, number 10. This is a battery power at all times. Let's check the meter. We have positive 11.7. Go ahead and load test it. Our light lights up nice and bright and 11.1. So that is a good power feed. Let's go ahead and check the next one. All right, so 11 and 12 are going to be ignition power feeds. I'm back probed right now on 11. We're gonna plug this back in. I'm gonna go turn the key on. Okay, so with the key on, we do have 11.6 volts. Let's go ahead and load test it. I'm gonna flick the switch. So you can see our test light lights up nice and bright. Our voltage is starting to drop though, but yeah, that's a good ignition power feed. Now let's switch over to pin number 12. Okay, we're on pin number 12. Again, key is on and you can see that we have full battery voltage. I'm gonna flick the switch. Our test light lights up nice and bright and you can see that we have about 11 volts right there. So that ignition power feed is good. At this point, we're done checking the powers and grounds on this connector. This one connector pretty much has all 3 powers and 3 of the grounds. However, there are a couple more grounds here on this C4 connector. So I'm gonna go ahead and pop this off and check those 2 grounds real quick. All right guys, so fast forward. I just got done load testing these grounds. Pins number 12, 13, and 14 on the C4 connector. They all tested good, so our job here is done. One other quick thing I'd like to mention is just for extra measure, I went ahead and did a pin fitment check on the terminal here for our C2 connector. Again, our diagnosis here is that the PCM is not sending out the pulse width modulated power signal to the alternator. So I wanted to check to make sure that we didn't have a problem with pin fitment. But as you guys can see, when I take this back probe and slide it in and out of the terminal, we have a nice amount of drag. It feels really good. This terminal is not spread open. And when I compare it to the terminals next to it, they feel exactly the same. So yeah, this thing passes a pin fitment check. There you have it guys. This thing's gonna need a new PCM. I'm gonna let the guys at the shop know. We'll have them order one and then we're gonna come back and program it. So please stay tuned.
1 week later.
All right guys, so fast forward. Unfortunately, the customer or the owner of the vehicle did not have the funds to replace the alternator, so I'm not able to show you guys the repair. However, luckily I actually have a 2013 Jeep Grand Cherokee in my driveway right now. Now this truck actually belongs to my mom. I have it here because I'm going to be replacing the lifters on this thing, quite possibly doing a DOD delete. Look out for that video in the near future. But what I really wanted to show you guys was a known good, fully operating alternator. Now, even though this is a Jeep Grand Cherokee and not a Dodge Durango, the powertrain, electronics, everything is all the same. We've got the same 5.7 liter V8 engine. We've got the same computer, and we've got the same alternator. I have 2 leads that are back probed to the connector on the back of the alternator. Pin 1 is going to be the yellow wire, which is our field control, and pin 2 is going to be the blue wire, which is our battery power feed. Once again, you can see I have the power probe connected, and right now we're showing 9 volts. The jump pack's a little bit low, but it's at 12.4 volts right now. Of course, the engine is not running, so I'm going to go ahead and start it up and show you guys what a known good should look like. Now, I must warn you before I start the engine up, the lifter tap is really loud, so I'm going to do my best talking over it. All right, so let's go ahead and crank the engine over. All right, and as you guys can see, right now we're showing 10.5 volts. Our alternator is charging at 14 volts. Let me switch this over to our pin number 1. Okay, so I went ahead and switched it over to the pin number 1. And as you guys can see, we have a fluctuating voltage. Now I can also click on this and show you guys a little graph. Let's see if that shows up on the camera. Yeah, if you guys take a look, you can see we have a duty cycle. That's what we want to see. We want to see some type of activity. Before, on the Durango, we weren't showing any of this. Sorry about the glare. Let me try to get you guys a better shot. Right there, you can see we have a duty cycle signal on and off. This is what a fully operational system looks like. Now let me go ahead and shut this engine off before it explodes. Well, there you have it, guys. Hopefully this video helps you out if you're running into a situation where you're not sure if your alternator is bad or you have a problem with your computer. Now in this case, even though we weren't actually able to see the fix on the Durango, I'm 100% confident that replacing the computer would have fixed the problem. Now, if you guys are interested in any of the tools that I used in this video, make sure to check out the description for links below. Like I always said, thank you guys for watching. I hope you found it useful, informational, educational, entertaining. If you did, make sure to give it a thumbs up. If you haven't done so already, make sure you subscribe to the channel. Also, if you guys don't already follow me on TikTok, make sure to go over there. I'll leave a link for the channel in the description down below. Thank you guys for watching, and I'll see you in the next one.